Okay, gentlemen. Yesterday we went over concepts. Now we're going to go over a little bit electricity closer to reality. But so let's recap yesterday. The concept behind the water flowing in a water hose was the water needed. If you want to get water from one place to another place, you need something to conduct that water. So the same thing with electricity. So electricity is a bunch of little electrons, which we're going to go over here in a second, that flow in a wire. So if you want to, just like water, you got to get it from one place to another. You need a hose. You can do the same with electricity, and you need a wire. All right. So anything that conducts electricity is called a conductor, just like a hose conducts water out. So a conductor anything that conducts I'm going to use electrons because that's what we're going to talk about today, electrons instead of electricity. Basically, electricity is electron flow. Now, there's all kinds of theories about whole flow. Electrons go one way, whole flow goes the other way, current goes one way, electrons go the other. And pretty soon you'll be so freaking confused. If you want to be an electrical engineer, you can get into all that. But I'm not going to try to confuse you guys. I'm trying to make things simple for you. So a conductor is a material. Okay, let's start here. Of all the material we have in the earth, there's basically three kinds as far as we're concerned. We have a conductor, we have an insulator, and we have a semiconductor. We didn't talk about semiconductors yesterday, so we'll talk about that right now. So we have a conductor, then we had, yesterday we had a conductor, then we had an insulator. Okay, so again, a conductor, this will be on your quiz. A conductor is anything that conducts electricity. An insulator is anything that does not. Now, granted, here we go again. There's always, oh, what if you have like a bazillion volts? Well, yeah, a bazillion volts will run across a lot of insulators, but we're just talking, you know, the common voltages that we use is a conductor will conduct electricity. An insulator will not conduct electricity. And then you have the third kind of material in the world. It's called a semiconductor. And it may or may not conduct. And that has to do with how many electrons are in the valence shell of an atom. And that is basically what class is going to be about today, all right? So the three kinds of material we have in the world, we have conductors, we have insulators, we have materials that conduct electrons, we have materials that don't conduct electrons, and we have semiconductors, which may or may not conduct electrons. So, what is an electron, okay? So, to go to an electron, stupid fly, to go to electron, let's talk about an atom. So, everything in the world is made up of atoms, all right? And we're not getting into quantum physics, we're just going simple stuff here. On the middle of an atom, every atom, they describe it as like a little solar system where we have the sun in the middle and we have all the planets that go around. So an atom is the same way. So in this atom in the center, like where the sun would be, you have protons and you have neutrons in there, these little particles. And so we're not going to talk about the neutrons, so we'll just put that to the side. I just want to try to be halfway accurate. So in the middle here we have protons, and they are positively charged, okay? That's the positive charge right there. And then going around here, like the planets in the solar system, we have these guys, and they are called, these guys right here, like the little planets going around the sun, these are called electrons, okay? And they are negatively charged. So those are negative. Okay, so again, conductor, insulator, semiconductor. The three kind of materials everything's made out of. And it all depends on the kind of atoms that are in something that makes it what it is. Metal atoms have, copper atoms have, copper is made out of copper atoms, and aluminum atoms are made out of aluminum atoms. But what makes an atom a different material is how many protons and neutrons it has, and how many electrons it has, and how many different shells that it has. Thank you. So the only ones we're concerned with is this outer shell right here, because we're not into, when you start changing this stuff in here, you're going to start changing, you know, actually what the material is. And I don't think that's possible. You can actually do that. Well, we can mess with this outer shell. Now, they have found out that a conductor is anything that has three or more, or three or less electrons in this outer shell, okay? They call this the valence, the shell, the out one. So anything with three or less electrons in the valence, this is called the valence shell, the outside shell, called the valence shell. Okay, so anything with three or less electrons. If you have an atom, you have protons and neutrons in the center, and you have a bunch of electrons. Like I said, we're only concerned with this outer shell. This outer shell, if it has three or less electrons, that means it can conduct electricity. It means it's a conductor. And that's because with three or less, those electrons are easy to bump off. They can bump off. They can take one more and it'll let one go. And these aren't attached. It seems like if there's three or less, they're not like really stuck on there. Where if you have an insulator has five or more, those electrons are stuck. They don't move around a bunch. Where if you have three, they share between different electrons. One will go over to another, one will go over to another. They bounce around, they freaking go everywhere. So these are kind of free if you have three, but if you have five, they seem to be stuck on there and they don't want to go anywhere. So if they're stuck on there and they don't want to go, since electricity is electron flow, you're not going to have any electron flow. If you don't have any electron flow, you don't have any electricity. So those electrons are stuck on that atom. They're not going anywhere. When you have 3 or less, they will take one or let one go, and they'll do this it's kind of a free-for-all. Probably like you guys at a freaking party. But semiconductor, now, we didn't go over this yesterday, but a semiconductor is going to be typically four electrons. And the reason that is because if you can get an electron to bump off of there, then it turns into a conductor. If you can get it to take another electron, it turns it into an insulator. So material that are semiconductors, they use that material for like switches. They can add electrons to it and make it an insulator. They can take electrons away from it, turn it into a conductor. So it acts like a switch with no moving parts. Just, that's kind of like, that's how your transistors work. But so electricity is electron flow. So when you have a wire, let's say this is a wire right here. All right. This is a wire, and this is made of copper, and it has all these little electrons in there. Copper electrons. Boom, 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 boom. Okay. So if I push a bunch of electrons in the end of this wire right here, they're gonna pop out right here. Okay. Because they're going to push, one will go to one atom. Like let's say you have another atom here. This one would jump on this one. This one would jump on this one. It would go all the way through here. It'll bounce out the other side. And this basically happens at the speed of light, which is 186,000 miles per second. Because this one little electron, it doesn't immediately go all the way through the wire and pop out. It bumps on one, it bumps on another, bumps on another, and it bumps one out the end. And that happens, so the effect of it is at the speed of light, which is 186,000 miles per second. So this is what electricity is. It's electrons flowing from atom to atom, bouncing from valence shell to valence shell. They're bouncing atom to atom, and they're moving. And this is electron flow is electricity. And what we do is we call that current, okay? So these electrons going down that wire, bouncing from atom to atom to atom, is electrons flowing in the wire. And we call that current flow. Equals electron flow, okay? Well, we're not gonna say that because you get into electronics and they call it whole flow and everything. So you're really not going to concern yourself too much as an electrician with current flow because you're going to be dealing more with amperage. Yeah, if there's no current flow and there's supposed to be, you got a problem. And if there's current flow and there's not supposed to be, you got a problem. But we always measure it in amperage, okay? Okay, amperage equals a measurement of electron flow. Okay, so how do you measure electron flow? Well, first thing is like, remember we talked about the hose. We had to, like if we put a hose in a 5-gallon bucket and it fills up 5 gallons, and it takes a minute, that's going to be 5 gallons per minute. It's just that simple. Or if you had a 1 gallon and you put the hose in there and you timed it for 1 minute, it'd be 1 gallon per minute. Well, the same thing with amperage is a measurement of electron flow. So before we can before we can measure electrons, you know, one electron is like freaking, we're talking about atoms. You can't like measure, well, we can't for our sake. I'm sure like some scientists in the lab can measure one electron at a time, but out here in the real world, we can't. We can measure a bunch of electrons at a time. Just like, you know, measuring a gallon or 10 gallons of water, we can do that. But most of us can't measure like some kind of microgram of water. So what we do, what electricians do is they measure coulombs per second. So they call a certain amount of electrons, they call it a coulomb, okay? And a coulomb one coulomb equals 6.25 times 10 to the 18th power electrons. Now, again, my big goal is to simplify things for you guys. And I believe if we calculate this out, this is like somewhere in the neighborhood of about 1 million electrons. It's not exactly, but we can just call it 1 million, all right? Just to say, I think it was 1 million. We calculated at one time. Our calculators didn't have enough zeros. But anyway, this comes out to about 1 million electrons. But that's just an amount. So now we got to figure out like the water. Okay, we have a gallon of water, but that don't tell us nothing. We need to have some time attached to it. So you let the water hose run in a 1 gallon jug and it fills up to a gallon. Well, that don't mean nothing unless we know how long it took. Same thing with a coulomb. You can just figure a coulomb is 1 million electrons. You can think of that as a gallon jug of water. But how long did it take to move 1 million electrons past a certain point? So what we do is 1 coulomb equals about 1 million electrons. So, and it's measured in amperage. So 1 amp equals 1 coulomb per second. Past a given point. So if you'd like say, like, let's say this is a big wire right here. So you would like say this is your point, and if 1 million electrons, if a coulomb of electrons passes by this one point in 1 second, then that would be 1 amp. If 2 coulombs pass in 1 second, it would be 2 amps, you know, and all the way up. If 500,000, a half a coulomb pass through here, would be a half an amp. But coulombs, just by themselves, is just about 1 million electrons. If they're sitting still, not going anywhere, you don't have any current flow, therefore you don't have any amperage because you got nothing passing by a certain point in 1 second. So again, current flow is just electricity flowing, okay? They say electrons flow in one direction, holes flow in a different, and that's actually current flow. For this class, let's just call current flow electron flow, okay? We're just going to defer to make things simple. So we have our current flowing, and then we need to measure it. And so what we do is we want to measure, we'll figure, okay, we'll get about 1 million electrons. If we get 1 million electrons go past a certain point in 1 second, we're going to call that 1 amp. And so that's why current flow is measured in amperage, okay? So again, current flow is, we'll just call it electrons flowing. And then we need to know how much is flowing. So we have to have measure like, okay, we're going to measure electrons. We'll say 1 million electrons are flowing. Okay, so how many are flowing past a point in 1 second? So we have a coulomb, which is about 1 million electrons flowing by one spot in 1 second, we're going to call that an amp. So amperage is a measurement of how many electrons are flowing. But you have to quantify how many electrons and how fast they're flowing before we can get a measurement. It's kind of like a friggin' your speedometer on your car. Okay, it's like 20 miles an hour. But if it just said 20 miles, that don't mean nothing. If it just said 1 hour, that don't mean nothing. You got to have you got to have miles. You got to say 1 mile is this far, and then you have to travel it, in this amount of time. So that's why your speedometer is set up 1 mile per hour, 2 miles per hour, 3 miles per hour. So you know how far you've gone in a certain amount of time. This is no different. Like how many electrons, instead of how far you've gone, this is how many electrons have passed by one spot in 1 second. So hopefully that helps you understand what amperage is. Now the next thing we need to talk about, because we're going to go into Ohm's law next week, we're going to talk about resistance, okay? Now, resistance is a measurement. Well, I take it back. Resistance is anything that opposes current flow. Granted, we have induction and everything else and capacitance, and we're not talking about all that. We're keeping things simple. Resistance, anything that opposes current flow, okay? Like that hose when I was squeezing it down yesterday. Now that is measured, you have to measure that in ohms. Ohms equals a measurement of resistance. Okay, again, for us to measure something, we need to quantify some stuff. So what they say 1 ohm equals the amount of resistance it takes to stop the amount, can't write that way. Okay, the amount of resistance it takes to stop 1 amp being pushed. We didn't put voltage up there. 1 amp being pushed by 1 volt. Okay. Let's review. Yesterday we have voltage, which is electrical pressure. Okay, so this is how much pressure. So we've got voltage pushing 1 amp, which is 1 coulomb per second. So if you have enough resistance to stop it, that would equal 1 ohm. So we talked about, let's see here, for Ohm's law, we're going to need to know amperage, this one right here, which is, you should understand what amperage is now. It's measuring the amount of electrons flowing by a spot in 1 second. And then we talked about voltage, the amount of pressure pushing those electrons. in this wire. How much pressure are we putting in here, okay, to push these electrons through? The resistance, the how much resistance there is, like copper has less resistance than aluminum, or if this was twice as far, it'd have twice the amount of resistance. So how much is resistance? How much work does this have to do to overcome to push this through, okay? Now, one last thing we talked about yesterday, we used the water hose to show we had pressure, we had the pressure of the water, and we had the water flowing, which was current flow. The pressure would have been the voltage, the current flow. And I squeezed the hose to simulate resistance, but that water was just running out in the air. Now, electricity doesn't normally do that. You need a complete circuit. So here's a symbol for a battery right here, okay? So there's a symbol for your battery. One side will be plus, one side will be minus. And so every circuit has to be complete so that these electrons, they can leave here, run through your load, energize your phone or a light bulb or whatever, and then run back to here. Now, they have more electrons on this side than they do this side. And so these electrons, since the negative is attracted to the positive, they'll run over here and they'll keep doing that until both sides are equal. Then they won't go anywhere, and you got a dead battery, and then you got to recharge it. So, but every circuit needs to have a voltage source, okay? Then every battery needs to have, every circuit needs to have a conductor. And every needs to have a load. Okay, so in order for you to have a circuit, this is called a circuit right here. In order for you to have a circuit, you have to have a voltage source, which could be a battery or a generator. It has to have wires, which are conductors. It has to have some kind of a load. So I am running out of time. I don't want to go too long. So we'll go over this some more, but this is getting you started here. We're going to review this tomorrow. But again, you need to know what a conductor is. Anything that conducts electricity. It has 3 or more electrons in the valence shell. An insulator, anything does not conduct electrons. It'll have 5 or more electrons in the valence shell. A semiconductor will have 4 electrons in the valence shell, and it may or may not conduct electricity, depending if you want to shove another one on there or take one off. Okay. Current flow is just the flow of electrons, and it's measured in amperage. And amperage is 1 coulomb, which is about 1 million electrons past a point in 1 second. So if you have a coulomb of electrons past a certain point in 1 second, that equals 1 amp. So just remember, about 1 million electrons passing by a point in 1 second equals 1 amp. In order for you to make those electrons move, you got to have pressure behind it. And you do that is like with water pressure, you got to pump that water up. With voltage, you got to pump all those electrons up. You got to shove a bunch in there, and it'll create pressure, and it'll make those electrons flow. We have a whole bunch of electrons here and no electrons here, then these electrons are going to flow around and get back to here. So now anything that slows this stuff down is called resistance, okay? And resistance, anything that slows that down is measured in ohms. And just so you know, 1 ohm is the amount of resistance it takes to stop 1 amp being pushed by 1 volt. So really, that's all you guys need to know. It's all has to do with atoms and how many electrons are in this outside shell. So what you do is you get those atoms to bump, you get those electrons to jump from atom to atom to atom, and that's how electricity works. And so then all you do is control it. You push more through there, you push less through there, you turn it off, you turn it on. Electricity is really not more complicated than that. So All right, gentlemen. I can see that we are out of time. I tried to go through that kind of fast. We'll do a review tomorrow, and then we'll have our quiz. All right, over and out. Anybody have any questions?